Okay, so looking at two quadratic equations, and these are trinomials, so that means there's three terms. So how they're usually asked is to factorize them. So we're looking at today is looking at why you'd use the minus b formula, so following on from the previous video. So looking at both of these, question 1 and question 2, okay, both of these are actually, and they can be represented as graphs. So anything that has like an x squared or an x or a y, they can all be represented as graphs. So what I've done is I've done out the graphs of question 1 and question 2. I've just done them down here, so I'm going to scroll down and have a look. So x squared plus 3x minus 4, that graph looks something like this. Okay, so it looks like that. It's kind of a U shape. Okay, where you have your minus 3 in and around there, your minus 1 around there, and your 1 there. And very similar here, your 3x squared minus 9x plus 5. That looks something like this. U shape again. Okay, U shape because it's a positive x squared. These are both positive x squareds. So it's a U shape. If it was a negative x squared, it would be like an N shape. And that's just the same graph, just zoomed in a bit more. Okay, so what we're going to do is looking at both of these questions, and what you've been doing is factorizing. So looking at question 1, and ask you if I actually have to factorize this, the first way we do it, and the way that we use the method we use the majority of the time, is the guide number. So that is looking at your number with the x squared. So the number with the x squared is 1. Okay, this is an invisible 1. Okay, so let's highlight this. So your x squared, or 1x squared, okay, so that's the number with the x squared is 1. You multiply that by your constant term. Your constant term is just your number by itself. That's our minus 4. So 1 by minus 4 is minus 4. You then look at and you think about your factors of minus 4. So the signs actually don't matter here. So I'm just going to do my factors of 4. And I'll do them in my grouping, so my pairs. So 1 and 4 is a pair of the factors because 1 times 4 is 4. And my next ones are 2 and 2. Okay, 2 times 2 will give me 4. Now you have to decide what signs are you going to put with your either 1 and 4 or 2 and 2. The aim is to get a plus 3. So a plus 3x to get your middle term. So for example, if I put a plus 2 and a plus 2 there, plus 2 will give me 4. So it's not 3, so that this one will be wrong. For example, if I did a plus 1 and a plus 4, that would give me 5. But I can see an answer here, and hopefully you can see it. If I have my plus 4 and a minus 1, it will give me 3. So now I'm going to change my 3-term algebraic expression into a 4-term. So I have my x squared, or 1x squared. Again, it's going to write x squared because that's how it's done in maths. My 3x is now becoming a minus 1x, so minus x, plus 4x. All I'm doing is I'm after changing my plus 3x to minus x plus 4x, and you still have your minus 4 equals to 0 at the end. So you still have your minus 4 equals to 0. I now have a 4-term algebraic expression, and I'm going to do my group and factorizing method. So I always do a dash line down the middle just to show that I'm going to factorize my first 2 terms, and then I'll factorize my second 2 terms. So look at my first 2 terms, my x squared minus x. I take out what's in common, which is x. I open up my brackets. X times what gives me x squared, it's x. And x times what gives me minus x, and that is minus 1. I do the exact same thing for my second 2 terms. Look at my 4x and minus 4, what's in common? That is a 4, so plus 4. 4 times what gives me 4x, so what gives me my first term? It's an x, so 4 times x gives me 4x. And 4 times minus 1 will give me minus 4. So that will equal to 0. And I know I'm right because my brackets, everything inside my brackets are the same. That's like your little hint to know you're right. How you finish writing this is you have x plus 4, so everything outside the brackets, everything not in a bracket. And you write down everything inside the bracket, and you only write that down once. Okay. How you finish off this is you put everything that's in your brackets equal to 0. So on my left bracket, I have x plus 4. You put that equal to 0. And you put everything in your right bracket, x minus 1 equal to 0. And to finish off, because we want to get an answer, we always want to find what x is, I'm going to bring my plus 4 across the equal sign, becomes a minus 4. And over here, I'm going to bring my minus 1 across the equal sign, and that will become a plus 1. So here are my 2 answers. I have x equals to minus 4, and I have x equals to 1. And this is really important, and it's really interesting to see on a graph what we actually found here. What we found here, so this is the graph. When we find the factors of this equation up here, which is the x squared plus 3x minus 4, we found exactly where this graph, this purple graph, cuts the x-axis. So we found an answer of x equals to minus 4. That is exactly the point where the graph cuts the x-axis. And we found x equals to 1, and this is exactly the point, x is 1 right in the middle there, where it crosses the x-axis. Okay, moving on to this one. So we used the guide number for this, and we got nice whole numbers. Okay, but sometimes you mightn't get, it mightn't cross the x-axis at exactly 1 or exactly minus 4. It might be 1.3562, and it might go on for a while. Looking at question 2. So question 2 says 3x squared minus 9 plus 5 is equal to 0. So to factorize this, again, I'm going to have a look at my guide number method that I did in question 1. I'm going to look at the number that's with the x squared. So the coefficient of the x squared here is 3. And my constant term, so my number by itself, is 5. So 3 times 5 is 15. Then I'm going to look at my pairs of factors of 15. So I always start at the first number, which is 1. 1 and 15 is one pair of factor. 2 doesn't go into it. 3 goes into 15 5 times. And that's all of my factors of 15. Now, I need to try and make a minus 9. Okay, same way I made the plus 3 on question 1. I'll try to make a minus 9 here. But using 1 and 15, I can't possibly get to minus 9. I could put maybe a minus 15 there and a plus 1 to be minus 14. Still not minus 9. I could put a minus 5 here and a minus 3 there to be minus 8, which is very close, but it's not minus 9. No matter what combination you try here, you will not be able to get to minus 9. So it's actually impossible to use your guide number method to solve this equation. That's when you use your minus b formula. So your minus b formula, and you can get it in your log tables, tells us minus b plus or minus the square root of b squared minus 4ac all over 2a. Now it does look like a lot of gibberish, but we know a few things. We know that our a is equal to the number whatever is the coefficient of the x squared. So the x squared has a 3. So we know a is 3. Similarly, we have b is the coefficient of the x. The coefficient of the x here is minus 9. Do not forget your sign. Minus 9. And we know our c is our constant term, which is just 5. And then you can plot it into your formula. So minus b, so minus 9 is plus 9, plus or minus the square root b squared, so minus 9 squared is 81, minus 4a, which is 3, and c, which is 5. That's all over 2a, and we know a is 3, so 2 times 3 is 6. Okay, I'm going to tidy up this side a small bit, so the square root. So it's going to be 9 plus or minus the square root of 81. And you can use your calculator for this. So you have minus 4 times 3 times 5, and minus 4 times 3 times 5 is minus 60 all over 6. And again, we can tidy it up another small bit. So we're going to have 9 plus or minus the square root, and 81 minus 60 is the square root of 21 all over 6. So we have our plus and minus here, and this is a bit where a lot of people get confused. Okay, you then separate your answer out. So I can have my 9, and I'll take my plus square root of 21 all over 6, and I'll do my minus over here, where I have 9 minus the square root of 21 all over 6. Now, if I asked you to put this maybe to 2 decimal places, you go to your calculator, you can type in 9 plus the square root of 21 all over 6, and you would get an answer with loads of those decimal points after it, but it's 2.26376, and it goes on for another bit. To round that to 2 decimal places, you would get 2.26. Similarly with your minus, okay, you put in your calculator 9 minus the square root of 21, and you put that all over 6, you would get an answer of 0.73623, and it goes on. But rounded to 2 decimal places, you get 0.74. So that means our answers now for this one, they're not as nice as question 1. They are decimals. So it's 0.74 and 2.26. Now, again, if you look at your graph, and this is what we're finding using the minus b formula and using our guide number. If you look at the graph and look very closely here, this is why I zoomed in here, the point 0.74, this is exactly where the graph touches or crosses the x-axis. I zoomed in a bit more so you can see it down here. This point exactly here where the purple graph, and the purple graph is our 3x squared minus 9x plus 5 equals 0. Zoomed in a bit more to show you that it is exactly 0.74 there. Similarly with this one, our 9 plus the square root of 21 over 6, that's 2.26. And that, you can see here, it's very close to it, but again I zoomed in, and you can see here that this point here is exactly 2.26. So that's what you're finding when you're factorizing questions and using the minus b formula. You're finding where your graph cuts the x-axis.